Hey everybody, this is Jared, Ajani, and Deontay, and we did the EIGRP setup for our network. That stands for Enhanced Interior Gateway Routing Protocol. It allows the routers to communicate amongst each other and figure out what's the fastest path between them across the networks and between nodes here. So just an overview of the network. We have Department A up here, Department B, and Department C, and then the remote host here. Each one is on their own IP network with their own subnet, and the interior networks between the routers are set up to incorporate just having two hosts between each port here. So for Department A, it's on the 154.64.1.0/28 network, which allows for 13 usable hosts in the network here. From this gigabit port here is registered as a 1.1 IP, and then this here is a 1.2. I didn't add all the hosts here for any of them really, just because it would clutter the space here. I wanted everything to look nice and neat. So yeah, there's 1.2. Down here in Department B, we have the 172.20.1.0/26 network, which allows for 62 usable hosts. More switches would be incorporated for here if we wanted to add more hosts, but I didn't do that. The gigabit port here is a 1.1. These two clusters of PCs that are represented, just the main one is a 1.10 here, and this one is a 1.20. And then we have the web server here. It's on the 1.5 for its IP address. For the router for Department C, we have 192.168.1.1 on a /24, which allows for 253 usable hosts. But we didn't need all of those, but it's the largest one that'll host or support 200 hosts. So each of these clusters represents, a few PCs, and obviously if we wanted to add more, we would have more switches down here. But this one is 1.100, 1.200, and then 1.225, and the file server here is 1.5 on the network. And then for the remote, I just used a 220.22.1.1/24 because it wasn't specified how many remote hosts would be on here. So I just made room for a lot of them. This port here is registered 1.1, and then this one is 1.2. So in between the routers here, like I said before, each connection has their own network, /30 network, which allows for 2 usable hosts. So from A to B, have it on a 10.0.0.0. So this is 10.1, this is 10.2. Across from B to C is 10.0.1.0. So this is 1.1 and this is 1.2. And from C to A is 10.0.2.0. So 2.1 and 2.2. Since there were no other serial ports available for all of these, since they're all connected to each other, in order to use the remote router, you could add serial ports, but we just use a crossover cable. Works just the same. It's on a 10.0.3.0 network, so this is 3.1 and this is 3.2.
Alright, so I'm going to demonstrate how to set up egrip between two different routers. Let me open up the command line interface. As you can see here, we have router 0 and router 1 connected via the serial port. I'm going to start by setting the host name for each router. Set command. Now I'm going to set the IP addresses for the gateways. This is the gigabit Ethernet interface. Now I'm going to do the same thing for the gigabit interface, the gigabit Ethernet interface on the second router. Now I'm going to configure the IP addresses of each serial interface on both of the routers. On this router, we will also configure the clock rate because it's connected via the DCE end of the cable. Now we're going to do the same thing for the second router. Now I'm going to display our configuration. Looks like everything's set up correctly. And now I can configure egrep on each router, and if it's configured successfully, it'll show that the neighbors are connected. Alright, now we're going to do the same thing for the second router. Alright, and as you can see, the routers can now see each other. Just to be safe, I'm going to ping from this router to the next one. And it's successful.
Hello everyone, Johnny Gibson here. I'm going to be going over a ping test with you on our egrep network. So I'm just going to select a packet right here and ping this random computer to this other random computer. You'll notice that it's now sending out ARP packets. ARP stands for Address Resolution Protocol. And what an ARP packet does is it helps translate logical addresses to physical addresses. So it's mapping the IP addresses to the MAC addresses. Okay, and you'll notice down here at the bottom it says our ping test has failed, and that's because even though it was sending it to the correct IP address, the IP address had no MAC address associated with it. So I'm just going to reset the simulation, and we're going to try it again. So you'll notice now that it's sending out ICMP packets. ICMP stands for Internet Control Messaging Protocol. These are just basic standard ping packets. They don't have any information. It's just a query relay. And there we go, our ping has been successful. egrep mapped out the network.
I also wanted to make a note on the ping test that Ajani did. If you do a live ping one that's not in simulation mode, so here I have a computer, the second cluster, which is the 172.20 1.20, I'm going to ping from the remote host, one of the remote host clusters. Do that, 172.20.1.20. You'll see right now it's processing the ARP packets to find the correct route to where it goes. It'll time out, but then after that it'll start replying, which is just the first packet. The first ARP packet goes out and it finds the route, and then it replies back to the host saying, hey, we found the route, but the ping never went through, so it'll say that it timed out. But after it's found the route, it'll send out another packet, ICMP packet, and it will go to the destination and bounce back. And that is the EIGRP network implementation. We hope you guys enjoyed.